All right, so we're going to do section 1.6 today. It's on parent functions. On the first day of school, we did the linear function y equals x. It's also this particular linear function, just for plain y equals x, is also known as an identity. And then we put all of this info in, so make sure that you have that one done. I have these little handouts for you, but if you're home at school today, you don't have them, so you can just kind of jot down the information and fill them in when you get back to school, or you can just put them in your composition book and just try to make sure you have a really nice graph. The idea is that you know your parent functions, but what I really need from you is that when we do section 1.7, you can make transformations based off of having an idea what it looks like in the first place. And then you have a quiz tomorrow where you have to be able to give this kind of information from a graph, and we'll do an example of that also in a few minutes. All right, so absolute value is another one that we did on the first day, so just make sure you have that one and all the information correct. So the new ones that we have done in class today are quadratic. So a quadratic, the generic parent function is just the plain y equals x squared. And so if you think about plugging in values, that's where I came up with the points for these graphs. We know that if we plug in -2, we get 4. If you plug in -3, you get 9. Plug in -1, -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. That's where those ordered pairs came from. And it's quadratic, so it's going to round, because if you did like 1/2 squared is 1/4. So you can get some good little points there. All right, domain, because it goes forever left to right, is -infinity to infinity. The range, it starts at 0 and goes up forever. So 0 with a bracket to say 0 is a good number, to infinity. It is not 1-to-1. It passes a vertical line test. It does not pass the horizontal line test. Every x has only one y, but you cannot say that the other direction. Every y does not have only one x. In behavior, as x approaches infinity, the graph is approaching infinity. As you move to the right, the graph is going up. As we move to the left towards -infinity, the graph is also going up. All right, y-intercept and x-intercept. X-intercepts are also known as zeros, is just the origin, 0, 0. Extrema, there is a minimum point at 0, 0. This function is increasing from 0 to infinity, and it's decreasing from infinity to 0. And then, yes, it's continuous. And then another thing you're going to have to answer on your little quiz is it even, odd, or neither? Well, this one has y-axis symmetry. You can fold it on the y-axis and everybody lines up. So that one would be an even function. All right, next we have the square root function, y equals the square root of x. And again, you know you can't do negatives because those are imaginary. The square root of a negative is imaginary. So we have to start with 0. Square root of 0 is 0. Square root of 1 is 1. The next pretty point is the square root of 4 is 2. And the next one is that the square root of 9 is 3. All right, so domain, start at 0 and go to infinity. Same thing with range. Start at 0 and it's going to go up forever really slowly, but it still is going to go up forever. All right, 1-to-1. It is 1-to-1. It passes the vertical and the horizontal line test. Our end behavior, as we approach infinity on the x-axis, as we move to the right, the function is going up, so it approaches infinity. As we move to the left, our function is approaching 0, and it doesn't go past 0, so we have to say it approaches 0. Again, it touches the x and the y-axis at 0, meaning that it also x-intercepts. It has a 0 at 0. Extrema, technically this does have a minimum at 0 because it reaches here. It doesn't exactly fit the definition, the fancy definition. It does fit it, but as far as thinking about it having points on either side that are higher, it doesn't, but the only points that it has are higher than 0. So 0 is a minimum. It is increasing from 0 to infinity. It's going up. It does not decrease. It is a continuous function. I can write it.
Sorry, the homecoming court voting is now open for all seniors to vote. If you would like to nominate anyone for homecoming court seniors, now the voting ad is live. Thank you.
Okay, I don't know if the thing picked that up, and I don't want to try to talk over it. Miss Marks just made an announcement that you can now vote for homecoming court if you are a senior. All right, so this is a continuous function, and this one would be a neither. It's not even or odd. It has no symmetry. All right, for y equals x to the third. That's a cubic function because it has a cube as the exponent. If we plug in some values, negative 2 to the third is negative 8, negative 1 to the third is negative 1, 0 to the third is 0, 1 to the third is 1, 2 to the third is 8, and you know it's going to keep going on and on and on. Domain is all real numbers, and so is range because it goes left and right and up and down forever. It is 1 to 1. It passes the vertical and the horizontal line test. In behavior, as we move to the right, we go up. As we move to the left, we go down. So as x approaches infinity, y approaches infinity. And as x approaches negative infinity, y approaches negative infinity. The only intercept we have is the origin. There are no extrema because there's no hills and valleys. It goes on up and down forever. It is only an increasing function. So from negative infinity to positive infinity, actually it's negative infinity to positive infinity, the function is going up. Not decreasing at all, not constant at all. That's not on here, but thinking about that. It is a continuous function because I can draw it without picking up my pencil. And this would be considered an odd function. It has origin symmetry. Everybody up here has a buddy down here. All right. A rational function. We have y equals 1 over x is known as the reciprocal function. Any function that has an x in the denominator would be considered rational. All right, so what happens here is you have, if you do, like let's say we put in a negative 2. That would be negative 2, negative 1/2. You put in negative 1 for x, you'd be at negative 1, negative 1. We put in 0 for x, we're undefined. So we have an asymptote that runs through x equals 0. So the y-axis is an asymptote. On the other side, if you put in a 1, you get 1. If you put in a 2, you get 1 over 2, so 1/2. If you put in a half, you get 1 over 1/2, or 1 divided into half-size pieces. So it would be 2. That's where this point comes from. As we keep going, we're going to hug the asymptote. So like if we plugged in a 8, you would get 1/8. If you plugged in a 20, you'd get 1/20th. And doing the reciprocal of that, if we plugged in a 1/4, we would get 4. If we plugged in a 1/10, we would get 10. So we hug those asymptotes. You have an asymptote at the x-axis and the y-axis. I know I just did my fingers backwards, sorry. Because at the x-axis, if you think about as you make x bigger and bigger and bigger and bigger, that fraction gets smaller and smaller and smaller and smaller, closer and closer to 0, but it's never going to be 0 because you could do 1 over 10 million, and that's basically 0, but it's not actually 0. So you have an asymptote of both axes, which makes writing your domain and range a little bit different because you can't say negative infinity to infinity. You have to show that you're going to jump over 0. So an interval notation that looks like this. This is 1 to 1 because it does pass that horizontal line test also. There are no intercepts. There are no extrema. This function is never increasing because if you try to trace it, you're going to go down slowly and then down fast. So it's decreasing here. Also on this piece, it's decreasing fast and then decreasing slowly. But again, you have to show that you're jumping over 0. Nothing's happening at 0. This is not a continuous function. I have to pick my pencil up to trace the picture. This function does have origin symmetry because everybody up here will have a buddy down here if I rotate 180 degrees. All right, last parent function is the greatest integer function, which is a special kind of step function. Step functions are functions that look like stairs, and they you did them in Algebra 2, hopefully, but it's a special kind of piecewise function as a step function. It's the ones that look like stairs, and then the special step function, the parent for that, is the greatest integer. And this is like a fancy little, looks like absolute value with brackets on it, and it's telling you, so we're going to have a couple of conversations, so some more information. What a step function does is it's our greatest integer function, is it's basically going to round down. It's the greatest integer without going over, is basically what's happening. So if you think of this as a line, what it's doing is taking all of the values that fall between here and here and rounding them down to that lower y value and making a little constant piece. So everything that would normally be here, we're rounding all of those y's down and flattening them out. And so they're closed on the left and open on the right, because if they were closed on both sides, you wouldn't be a function because you wouldn't pass the vertical line test at any given overlap. So we have a domain of all real numbers. Our range is just integer values. There's no decimals and fractions involved. This is not one-to-one because it won't pass a horizontal line test. It has a y-intercept at 0, 0, an x-intercept at every x value between 0 and 1. And you see this whole little chunk, those are all x-intercepts. There are no extrema. It is never increasing, it is never decreasing. It's constant, and it'd be really hard to write that, and it's not asked anyway, so that's not important. It is not continuous. I cannot draw it without picking up my pencil. And it's not even or odd. It would be a neither if we were answering that question. All right, I think this is out of order from how I did it, but it's still all the same information. So make sure that you've written this down, pause and write it down. Evaluating a step function, just to make sure we understand. 5.2, you're always going to round down to the integer that's less than. So 5.2 rounds down to 5. 6.7 still rounds down to 6. Normally you would say round 6.7 up to 7, but the greatest integer isn't always round down. All right, negative 1/2, we're always going to round down, so that actually goes down to negative 1. All right, so some practice evaluating some uglier ones. We have these. We're going to talk through. If I'm evaluating for the greatest integer of x plus 4, you have to plug in the value, figure out what it is, just like with absolute value, and then do that greatest integer part. So plug in negative 3/2. Negative 3/2 plus 4 works out to be 2.5. And then you do the greatest integer, which rounds it down to 2. Plug in a 1. 1 plus 4 is 5. Do the greatest integer, it's still 5. We put in a negative 9/2. Negative 9/2 plus 4 is negative 1/2. If we're going to take negative 1/2 and round down, it's going to go down to negative 1. All right, next example. I would say pause and try it and then see how you do. Well, don't pause. You can't see. Okay, now pause. All right, so plug in 1/8. So we do 1/8 plus 4, just follow order of operations like normal, so 4 and an 8. Do the greatest integer, and that's just a 4. Then multiply by negative 7 and subtract 6. All right, so we do a negative 4. Negative 4 plus 4 gives me 0. Greatest integer of that is 0. Multiply by negative 7, subtract 6. All right, so then the next thing in this lesson, and I don't think we're going to get this far, so I'm going to go ahead and stop the video. I think tomorrow we will pick up with graph piecewise functions, and then we'll do another example of this, writing a linear function, giving 2 points in function notation, and then we'll move on to transformations of functions, section 1.7. So the other thing that I want us to talk about, and I wasn't prepared, so give me a second to make this happen, is an example, there it is, an example of what your quiz is going to look like tomorrow. All right, so if I'm going to graph this, I can graph it on my calculator. So go to y equals, type this in, and look at what the graph shows. So I feel like I'm fixing to make you like jump back and forth from things. But if I go to y equals and I type in x to the third minus 7x and hit graph, I get this picture. So to get a good picture, we talked yesterday about how we need to know where this max and min are, and we need to know those zeros. So the zeros, we know 0, 0 is 1. So we got to figure out these other guys. So if we go second calc and say I'm looking for a 0, so number 2. And then we have to move our cursor until it's a little to the left. So like, I think that my 0 is like right here. So a little to the left is going to have to be down here because that'll be an x value that's less. So we'll go here, hit enter, half it up, so that you're to the right of it, hit enter for a guess, And we know negative 2.65. Alright, so now let's go find the other one. Second calc. We're looking for a 0, so number 2. Now we got to move our cursor till we are a little to the left, which is going to be right there. Then move it so we pass it up, and then hit enter for a guess, and we get 2.65. It's a symmetric graph, so it should be pretty good. Alright, so on our paper, we know the zeros, so we can put zeros roughly here, and we had one at 0, and roughly here. Alright, so then we need to go back and look at our min and max. So this one has a maximum and a minimum. So if I want to find that maximum point, we're going to go second calc. And say we want a maximum. And then we have to move our cursor a little to the left of that high point. And a little to the right. And then hit enter for a guess. And we get that the maximum point is at negative 1.5 and 7.1. Alright, so then let's go figure out the minimum. I'm writing these down so I don't forget, so that when I go back to the slideshow I can put them in the right place. Alright, minimum. So now we're going to move to that low point. We're going to stop a little to the left, pass it up so we're a little to the right, hit enter for a guess, and we're at about 1.5 and negative 7.1. Alright, so once you have that information, you're really done with your calculator. Now it's what do you know? So let's see, negative 1.5 and up here a little above 7. And then positive 1.5 and down to a little below 7. I'm not looking for perfection, I'm looking for your points are in about the right place. Alright, so if I'm going to graph this, we know from the picture that this goes down forever. Your picture has to be way better than mine. I'm drawing with the mouse. So we're going to give me lots of grace. This should be a lot smoother on your paper. Again, I'm trying to draw on the computer with the mouse and it's quite horrible. Alright, so domain is going to be negative infinity to infinity. Ooh, Lord, help me. Okay. Range will also be negative infinity. Let me slow down and see if I can make this actually look decent. There we go. Alright, it is not 1-to-1 because, like, all of these points would not pass a horizontal line test. In behavior, I'm going to say it, not necessarily write it. So as x approaches infinity, so as we move to the right, we go up. So we would have y approaches infinity. As x approaches negative infinity, y is going to approach negative infinity. Y-intercept is only at 0, 0. Your x-intercepts are going to be all three of these points that you got with your calculator. So 0, 0 is 1, and then you have these other two. So there should be 3 ordered pairs there. This ordered pair, the 0, 0, and this ordered pair that we found. Local extrema, you found your max and your min. So write those down, max and then the ordered pair, min and then the ordered pair. Increasing, decreasing. So this function is increasing, then it's decreasing, then it's increasing. So for increasing, to start with, it goes from negative infinity, and it goes up to this negative 1.5. And then it increases again, starting at positive 1.5, and going to infinity. It's decreasing in between those, so from negative 1.5 to positive 1.5. Again, the mistake that people make, and the reason that I'm writing this one down, is that people want to use y value. So it's not the 7.1, it's the 1.5, the x part. Alright, even, odd, or neither. So do you see how when we did our max and min, they're like opposites of each other? that's a clue that it's odd. It does have origin symmetry, so this is odd. Alright, I know I didn't fill all that in, so if you have a question about something, let me know. Rewind and re-listen to what I said so you can make sure that you have all of that right. We will finish this section up and do 1-7 tomorrow. The assignment for tonight is just last night's homework that I told you wasn't due until tomorrow.